Today we're going to be talking about area between two curves. Now remember, when we're taking the integral of something, when I take the integral of f of x dx, what that means is the area from a to b, some x restrictions, all the way down underneath our curve to the x-axis. But what do I need? I need just the area in between these curves. So what I need to do is I need to take away here the area under our curve of our g of x curve. So what we need to do then is we need to take away the area under our curve of our g of x term, or our g of x function, I should say. So therefore, to find the area between two curves, going to the x-axis, we have the integral from a to b of our f of x function minus our g of x function dx. Okay, so I always think about it as the top function minus the bottom function, or the farthest function from our x-axis minus the closest. Actually, let's think about it that way. Far minus close. Okay, our first example. We're finding the area of our shaded region. Okay, they intersect at the point of 1, 1. So we have the integral from 0 to 1 of our top function, or the function farthest away from our x-axis, is root x minus this function here is the bottom function, x to the third, and we're taking the area in relation to x. So taking that integral, we have 2/3 x to the 3/2 plus 1/4 x to the 4th from 0 to 1. Plugging in and evaluating that integral, we get 5/12. Now be aware, these are going to be both non-calculator and calculator questions. Okay, so keep in mind you're going to have to do some of this algebra plugging in 1 without a calculator. So keep that in mind. Our next example. Notice the symmetry that we have here. Notice how this area to the left of our x-axis and the area to the right of our x-axis, our graphs are symmetric. So we can just take twice the integral from 0 to 3. Now we have one function here. That function there is 5x squared. So that's the function that's on top, 5x squared, or farthest from the x-axis, minus, now the function that's on the bottom, and even though a little bit dips below the x-axis, this minus sign is going to take care of that. X to the 4th plus 4x squared. Okay, I distributed the negative to change that to a plus sign. And we're finding our area in relation to our variable x. So now what I recommend before you do anything, combine like terms. I take my integral 2 times our integral, and we're evaluating from 0 to 3 of 3x to the 3rd minus 1/5 x to the 5th. Okay, I plug in 3, and when I plug in 3 there, we get 162 over 5. When I plug in 0, that just goes to 0, so that's why I don't have to worry about that. So we get 324 over 5, which equals 64.8. Okay, so again, calculator and non-calculator. You're welcome to check your answers with your calculator, but if you can take the integral, if this is an easy function for you guys to take the integral of, I want you guys to be trying them without your calculator. Now, what if your functions are in terms of y? So I guess they're technically not functions. What if your equations are in terms of y? Okay, then you're going to take your integral with respect to y. You're going to go, and everything's going to be in terms of y. So this c value is going to be in terms of y. Those are going to be y values that you're taking the integral from. Now again, you're looking at the area to the y-axis now. So you take your farthest function minus the closer function. So when I take and I do that integral, that's going to get us the area to our y-axis, or area between our curves, I should say. Now notice how these functions, okay, they both are in terms of y. And it looks like our area is a region in relation to our y-axis. So we're going to be integrating everything in relation to y. So I'm going to be looking at the area from the point 0 to their intersection point up here, which is 1. Now it's going to be hard for you guys to think, okay, which one do I do? Which one minus the other one? Okay? You always take, and I was saying farther minus closer, what's hard to determine which one's the farther, which one's the closer here. So you're going to take the 12y squared minus 12y cubed minus the negative function, minus the one that's to the left of our axis. dy. Now make sure that's a dy. I'm taking my integral. Notice how everything is in terms of y. That's why I need this dy. So now taking that integral, actually simplifying that guy first, so taking that integral, from 0 to 1, when I evaluate that integral, you get your area to be 2. So integrating with respect to y, you do that if your function's all in terms of y. Okay. Now this next example, I actually want to do this one 2 different ways. Okay. Because it's easier if we do it in terms of y, but I want you guys to realize that if it's in terms of x, we can also find the area, and we're going to get the area the same both ways. So if I do this in terms of x, there's a challenge with this one because our function that's farther away and our function that's closer, they change. Right there. So we're going to look at this as area 1 and area 2. So area 1, when I'm finding my integral, we're going from 0, everything's in terms of x's, to 12, because that's where our function changes from y equals x being on top to y equals 12 being on top. So you're going to take the far function, which is y equals x, minus the bottom function, which is x squared over 48, and you're going to add to that the area of region 2. So that's from 12 all the way over here to 24. Now your function changes. Now your function, the function on top is 12, because when I draw up a line, that's the function that's on top, minus this crazy x squared over 48. Ooh, I forgot my dx. A dx there and a dx there. So finding these integrals. Okay, so finding these integrals, we have 1/2 x squared minus x to the third over 144, evaluated from 0 to 12. And then we add to that our 12x minus x to the third over 144 from 12 to 24. Personally, I would let you guys use a calculator on this. I'm not going to go through that algebra of plugging everything in, but we do get our value of 120. And that was with everything in terms of x. So I was looking at the area to the x-axis. Now let's look at this now in terms of y. Okay, so now if you look at it like you're looking and you're going to the x-axis, I'm sorry, the y-axis. So what's drawing from your y-axis over, what's the farthest function? The farthest function is y equals x squared divided by 48. This function needs to be solved for x. So I'm going to have 48y equals x squared. Okay, this is this function in terms of y. Because when I integrate, I need the functions to be in terms of y. So I solved for y, and the square root of 48y is my farther function away. And then our closer function, as I'm drawing a line from my y-axis over to our function, is the line y equals x. So we're going to subtract y. Everything is going to be in terms of dy because we're integrating to the y-axis. We're finding the area to the y-axis. And then what's your y restrictions? What's the smallest y value you go to? What's the largest y value we go to? We're integrating the area of these two curves from 0 to 12. Okay, so when I do the integral of that, what did I do here? I took and I separated this out into root 48y, root y, I apologize, minus y dy. And I went through and did a little bit of algebra. And I got, when I took my integral, I got root 48 times 2 over 3, because my new exponent is to the 3/2 power for this first term, minus 1/2 y squared. And I evaluate from 0 to 12. And I promise, with a little bit of work and plugging in my calculator and simplifying radicals, we do get 120 also. So in terms of y, we have a less scary integral. In terms of x, we had to split it up into two functions. Now, talking about splitting up into two functions, one function always needs to be the function above versus the function below. So I'm highlighting our blue curve, which changes. The function that's on top changes halfway through our area. And then the other function I'm going to put in purple is this function. Okay, so when I'm taking the integral, I have to split it up into two areas because the function that's above and the function that's below changes. So we're going from -4 to 0. The function that's above on that interval is x cubed minus x squared minus 14x. I'm going to subtract from that a function that's on the bottom, which is a negative x squared plus 2x. And then we're taking our integral with respect to x. Since these functions were both in terms of x, we're going to add to that the integral from 0 to 4. Now which function is the one that's above? The one that's above is negative x squared plus 2x. we're going to subtract from that x cubed minus x squared minus 14x dx. So now that's just a bunch of algebra going through and finding each one of those integrals, okay? Simplifying. So simplifying the top one, we get from -4 to 0 of x cubed minus 16x dx. And then we have our area under our curve from 0 to 4 of negative x cubed plus 16x dx. So finding each one of those integrals, we have 1/4 x to the 4th minus 8x cubed from 0 to -4. We're going to add to that our negative 1/4 x to the 4th plus 8x squared from 0 to 4. Finding that, plugging in all our numbers, I'm not going to go through that with you guys, we get 128. Okay, that is it for our area between two curves today. Please make sure your lesson summary is submitted on time.